Hello everyone. This time I want to share my experience on how to download data from Kaggle to Amazon S3 in a short tutorial. All you need is an AWS account and a Kaggle account. I use CloudFormation in this tutorial. Don't worry if you don't understand CloudFormation, the context is we are learning together here. The Steam Reviews Dataset 2021 is a comprehensive collection of user reviews for various games available on the Steam platform. This dataset encompasses a wide range of games, capturing diverse user experiences and opinions. Each review includes details such as the game's name, the user's review text, and the date of the review, providing valuable insights into player feedback and sentiments. Researchers and data enthusiasts can utilize this dataset to analyze patterns in user feedback, identify common themes, and assess overall player satisfaction across different games. By examining the textual content of the reviews, one can perform sentiment analysis to determine the general sentiment, positive, negative, or neutral, expressed by players. Additionally, the dataset allows for the exploration of trends over time, such as how player opinions evolve with game updates or changes in the gaming industry. The dataset is particularly useful for developers and publishers aiming to understand player preferences and areas for improvement. By analyzing the reviews, they can identify recurring issues or popular features that resonate with the gaming community. This feedback loop is essential for enhancing game quality and aligning future developments with player expectations. Moreover, the dataset serves as a valuable resource for academic research in fields like natural language processing, sentiment analysis, and consumer behavior studies within the gaming industry. This is my simple solution. I start EC2, put it in public subnet, then download the file using curl command. Extract the data, then save it to S3 bucket. Using Amazon EC2 for data transfer provides significant advantages in terms of performance, security, cost efficiency, and scalability. Firstly, the performance benefits stem from the high-speed data transfer capabilities within AWS, enabling quick and reliable data movement across resources in the cloud. This is particularly useful for applications that need to handle large datasets or operate in real time, as EC2 instances can be optimized to support intensive data transfer workloads. Additionally, AWS's global network infrastructure ensures that data transfers remain consistent and high-performing, especially for organizations with complex multi-region architectures. Security is another vital benefit, as using EC2 for data transfer minimizes exposure to public internet threats. By keeping data transfer within AWS's private network, it reduces the risks associated with public internet exposure, such as data interception or unauthorized access. Cost efficiency is also a major consideration. Data transfers within the same AWS region are often free, reducing the overall cost of transferring data across different services. Lastly, scalability is seamlessly handled through AWS's automated scaling capabilities, which allow EC2 instances to adjust based on demand. This elasticity ensures that data transfer capabilities can grow in response to increased workload needs, maintaining high availability and operational resilience without requiring manual intervention. In this tutorial, I downloaded data from the internet. However, if the data is already in AWS, then the advantages mentioned above can be used. I also use a public subnet in this tutorial, so that this tutorial is easier and shorter. However, in an ideal environment, you can put the EC2 machine in a private subnet. This increases the security of your data. You can use a Bastion host to connect to the EC2 in a private subnet. This is the link of the data I used. Before downloading this file, I already had a Kaggle account. The ER5.4's large instance type is ideal for downloading files less than 10 GB from the internet due to its balanced combination of memory, processing power, and network capabilities. With 16 and 128 GB of RAM, this instance can efficiently handle moderate data processing tasks without overwhelming system resources. Its ample memory enables efficient management of network connections and ensures that downloaded files can be processed or moved with ease. Additionally, this instance supports high-throughput network connections, which can help in achieving fast download speeds, minimizing the time required to retrieve data from external sources. Moreover, the 10 gigabits per second network capacity of the ER5.4's large provides substantial bandwidth, allowing for rapid data transfer speeds, even when downloading multiple files or when handling connections with high latency. This high network throughput, combined with the instance's cost-effective nature, ensures a balanced approach to performance and cost. For data transfers of this size, less than 10 gigabytes, this instance type can easily meet demands without incurring the high costs associated with instances designed for larger workloads, making it an optimal choice for data-intensive but moderate-sized file transfers. The conclusion emphasizes three main advantages of using AWS for data transfer: scalable infrastructure, secure transfer, and cost-effectiveness. AWS's scalable infrastructure enables users to leverage cloud resources that can adjust to varying workloads, making it easier to handle both small and large-scale data transfers without the need for constant manual intervention. Secure transfer protocols ensure data security during the transfer process, protecting sensitive information with encryption and compliance with industry standards. Lastly, AWS's cost-effective solutions allow businesses to transfer data efficiently without incurring excessive costs, providing a balanced approach to performance and budget. While utilizing an Amazon EC2 instance for downloading files under 10 GB is feasible, leveraging AWS services like Amazon EC2 Autoscaling or AWS Data Sync can enhance efficiency and scalability. Amazon EC2 Autoscaling automatically adjusts the number of EC2 instances based on demand, ensuring optimal resource utilization and availability. This is particularly beneficial for applications with fluctuating workloads, as it maintains the desired performance levels without manual intervention. Alternatively, AWS Data Sync is a managed service designed to simplify and accelerate data transfers between on-premises storage and AWS storage services. It automates data movement, handles large-scale transfers efficiently, and ensures data integrity and security during the process. By integrating these services, you can achieve more efficient, scalable, and secure data transfer operations within the AWS ecosystem.
This AWS CloudFormation template automates the creation of a virtual private cloud or VPC with a public subnet, and then an Amazon EC2 instance configured for AWS System Manager SSM access, and an Amazon S3 bucket with a full access granted to the EC2 instance. The template begins by defining two parameters. First one is project name, and then the second one is random string. The project name, which sets the base name for the resources, defaulting to copy-public-data-2-AWS. And then for the random string, a default string used to ensure the resource name uniqueness. Then for the networking components are then established, including a VPC with the CIDR block of /26, DNS support, and hostname enabled. An internet gateway is created and attached to the VPC to facilitate internet access. A public subnet within the VPC CIDR blocks /26 is also configured to assign public IPs to instance upon launch. A route table is also associated with the VPC, and a route is added to direct all outbound traffic 0.0.0.0/0 to the world through the internet gateway. The public subnet is then associated with this route table. Security configurations include the creation of a security group that permits SSM access and intra-group communication. An egress rule allows all outbound traffic from the security group, and an ingress rule permits all inbound traffic within the security group, enabling internal communication. Then I create S3 bucket named using project name and random string parameters, providing a storage solution accessible by the EC2 instance. The template defines the IAM role that the EC2 instance assumes, granting permissions for SSM and full access to the S3 bucket. An instance profile is created to associate this IAM role with the EC2 instance. Notably, the IAM role includes the Amazon SSM Managed Instance Core Managed Policy. This is because enabling the EC2 instance to be managed via AWS System Manager. This configuration allows for secure and auditable access to the instance without the need for traditional SSH key pairs, because I don't want to connect to this EC2 instance using SSH key pair. An EC2 instance type of R5.0 for XLarge is launched using a specified Amazon machine image. It is configured with the IAM instance profile and the security group, and is placed within the public subnet because it needs to talk to internet. The instance includes a block device mapping for 128 GB EBS volume. Additionally, an extra 128 GB general purpose SSD or GP2 EBS volume is created and then attached to the EC2 instance at the device/dev/SDH. And then the EC2 instance is intentionally placed within the public subnet to ensure it has a direct access to the internet. This configuration is necessary for the instance to download the data from the external sources or communicate with external service. By utilizing AWS System Manager for instance management, the need for traditional SSH key pairs is eliminated. This approach Of course, enhance the security by reducing the attack of surface and simplifies access management. The CloudFormation template is designed to be self-explanatory with a clear parameter definitions and resource configurations, I think. So for further details to access the template, please visit my GitHub repository. I will give the link at this video description. Previously, I already had a GitHub account. I have also created a program code repository on GitHub. Open your GitHub repository, then select Actions. On this page, you will find which commits have been running. I want to see the last commit because this commit is the one being run by AWS CloudFormation. The orange color on the actions is a sign that this process is running. The page displayed shows the AWS CloudFormation console for a stack named download data using EC2 RT10XM, which is currently in the process of being created. This is indicated the create in progress status. CloudFormation is a service that enables users to provision and manage AWS resources through templates, automating infrastructure setup. This stack creation was initiated by the user to set up specific resources defined within the CloudFormation template. The user is GitHub. The stack creation started at November the 3rd, and then the main purpose of this stack is to create a VPC with a public subnet, launch an EC2 instance with SSM AWS System Manager access configured, and then set up S3 bucket that grants EC2 instance full access. On the left-hand side of the page, there is a stacks panel displaying a single stack with the name download-data-using-EC2-RT10XM and its current status create in progress. This panel helps users manage multiple stacks in their AWS account, providing a list of views that can be filtered by status. For example, active or deleted, but currently right now because I only have one stack, you can only see one stack in here. In this case, the filter is set to display active stacks. Users can click on individual stacks to view more detailed information, including stack resources, events, output, parameters, and then the template used. The console allows users to drill down into this specific section to troubleshoot, verify settings, and review progress as CloudFormation builds out resources. The central section shows the stack info tab with the detailed stack information such as stack ID, description, status reason, and creation timestamps. The stack ID is a unique identifier for this particular CloudFormation stack instance, enabling tracking and logging purposes. The description provides a summary of the template purpose, outlining that we set up VPC EC2 instance in S3 with a specific configuration. Key attributes such as whether this stack is a root stack or part of the nested structure and the status of drift detection, currently not checked, are also visible. Drift detection is useful to determine if any manual changes have been made to the stack's resources outside CloudFormation, which can affect the stack integrity and automation. The page displays the Events tab for the CloudFormation stack. The Events tab shows a log of action taken by CloudFormation as it creates, updates, or deletes resources specified in the template. Each event entry includes a timestamp, the logical ID, the name or identifier used in the CloudFormation template, the current status of the action, and if available, additional details. This tab is particularly useful for monitoring stack creation progress and troubleshooting any issues that might arise during the deployment process. The events are listed in the chronological order, with the most recent events appearing at the top. Some of the entries include resources like all traffic egress rule or self-referencing ingress, instance, security group, etc., has status of a create complete, indicating that the security group was successfully created. Other entries like all traffic egress rule and self-referencing ingress shows a status create in progress, meaning that CloudFormation is still working on these components. These events help provide transparency into the CloudFormation process, allowing users to see which resources have been successfully created and which are still pending. This view is beneficial for identifying where a stack might be stuck. If a resource has taken too long to create or fails, due to configuration errors or resource limitations. The user can also search for a specific events or refresh the view to get the latest updates on the stack progresses. Our CloudFormation stack creation is complete, Alhamdulillah. If you check GitHub, you will get a green check mark, which means the command that has been sent to AWS CloudFormation was successfully executed perfectly. This is the resources tab. We can see that the resources we create were all successful with the status create_complete. Create complete. This is the output page of the AWS CloudFormation. This page contains various parameters that we fill in from the CloudFormation template in the outputs section. Let's navigate to the EC2 that we have created. We will try to connect to this EC2 using SSM System Manager. This AWS EC2 instance detail page provides information on a specific instance, labeled as copy-public-data-2-AWS, etc., etc. The instance is currently in a running state, indicating it is actively operational. It utilizes the instance type of R5.4xlarge, a high-performance instance type optimized for memory-intensive applications. The page provides crucial details, including the instance public IPv4 address 16.78.32.38, which allow it to be accessed from the internet, and a private IPv4 address 10.0.0.60 for a communication within the VPC. Additional network configuration details include the private and public DNS names, which assists in network resolution for both internal and external communications. The instance is associated with the VPC ID, this VPC-0C, etc., etc., linking it to its virtual private cloud. The elastic IP section indicates the absence of an attached elastic IP, meaning the public IP may change upon stopping and starting the instance. Additionally, this page includes an option for AWS Compute Optimizer recommendations, which can assist in assessing the instance resource utilizations and potential optimizations for cost or performance. Okay, you can press this connect button if you configure SSM to connect to EC2. Okay, now I'm inside EC2. I switch to where the Kaggle dataset should be. This is an empty S3 bucket display, proof that the data has not arrived. Let's refresh this S3 bucket again. Alhamdulillah, the file has arrived in the S3 bucket. That's my tutorial this time. Hopefully it's useful. Don't forget to like, comment, and subscribe to this channel. See you next time.